And there are also things that we're going to get from the things that are given. We're going to highlight all the given things on our diagram. So what are the things which are given? If you check with what is it that you are given that you have triangle PQR. So that's a triangle is PQR. Now, what is wrong with PQR? Why we can't use PQR? PQR doesn't have any parallel lines on it. So even if we wanted to use PQR, it doesn't work because there is no line which is parallel to any of the sides. Like you have PR, there's no line parallel to PR. There's no line parallel to PQ. There's no line parallel to QR. So that one doesn't work. But now we do have parallel lines. The parallel lines are going to give you the triangles that you are going to work with. So what are the parallel lines? The parallel lines are your PS and TV. So these two lines are parallel. Okay? Now, what do the parallel lines give you then? It gives you the triangles that you can use. The triangles that you can use, as we are saying you can use PSV.
Yes.
Or PSV, PSR. So we can use triangle PSR. And then they say PSR, we have PS, which is parallel to TP. Why is this important? This is important because it's going to give us proportionality. If you have parallel lines, then you can use the prop theorem. This line is going to be in proportion. This side is going to be in proportion with this side. So we're going to have a proportionality theorem there. And then what else do we have? This is not the only triangle that we have. We have this line, which is parallel to this one. So we also need that triangle. So if we take this triangle out, then we're going to have T, B, Q. And then with TV, you have TV, which is parallel to US. Now, why do we need this? Here you're going to have proportionality theorem. This one and this one, they're going to be in proportion with this one. Now let's go and check what are the ratios which are given. There are ratios which are going to be given. Let's go and check what are the ratios which are given. We are given SQ. So you go from S to Q. From S to Q, they say it's 2. Okay? Then you can say this is 2 parts. And then you have SR. You can say with this one here, it's going to be 3P. Now, if you say this as a ratio form, if you can write this as a ratio form, you can say you're going to have 2P all over 3P. P and the P are going to divide each other out. Then you're going to be left with 3 all over 1 all over 2. Now, why do we put the P here? We are saying because we're talking about the ratio. When we talk about the ratio, we represent them with a variable. So if it's a length, you will simply write it. If they were saying it's 2 centimeters, I was going to write it as 2 centimeters, no P. Now, what else do we have? We also have this other ratio, TP all over TR. So where is TP all over TR? So you have TP all over TR. They say this is 2:7. Again. So it's going to be 2:7. But now it's a ratio. We can't write it as 2 and 7. Again. Then we're going to use a different variable here. We'll use 2K:7K. Any variable you can use about PQR, doesn't matter. But you can stay away from X and Y because usually you'll find which they will say determine what is going to be X. Okay, so we have 2K:7K. Now let's go and represent them on our small diagrams that we took out. So this one, it has PT. It means which this one is 2K:7K. That one is fine, right? Yes. We get it from this one here. It's just what representing it here on the small diagram. Let's come to this one here. On this one here, we have QS again. What is QS? 2P. Now, what is SV? From S to V, we have no idea. As far as what is S to V. So we're not going to write anything. Now, this is what was given. We are done with what was given. Let's go to get things that we can get from proportionality theorem. What are the things that you can get from prop theorem? You can get SV is going to be SV is to VR can be written as 2:7. So we're going to write that because we're getting it from proportionality theorem. I'm going to say SV all over VR is going to be equaling to PT all over TR. Now, this was not given. I need to tell them why am I saying this, because it was not there. So this one was not there. I'm going to tell them which I have a line parallel one side triangle. Now we know what is PT. What is PT? It's 2K. What is TR? Okay, 7K. And then K and K, they divide each other out. It means with the ratio, it's 7:1:2. Or it's 2:1:2:7. But this is a ratio, guys. When I represent it on my diagram, look at what I'm going to do. This is 2:7, but I'm not going to represent it as 2:7 because it's a ratio. I'm going to represent it using a variable. I can't use the same variable as this one here because the lengths are not equal. So I need to come up with a new variable. So which variable I haven't used? Any variable that I haven't used here. I'm going to call this one what? R. Let me call it 2R. Let me call this one 7R. That was it. That one is fine. So let's come and check here. This diagram here has SR. This diagram here, it also has SR. No, it's SV actually. So we have SV, and then here we also has SV. So we can come and represent this one here and say, this one here is given as 7R. This one here is given as 1 as 2R. Let's come and update our diagram now. On our diagram here, you're going to put 2R here. I'm sure that one is 2R. Now, what are we looking for, T? We are looking for QU all over 1 all over T. Let's go and check if we can get that. Let's try and check if we can get that. Now, if we try to get that, then what are we going to have? We are going to have QU is what we're looking for. All over UT. Now, what you get QU and UT, you get it with this diagram here. This is the diagram that you're going to use. It has QU all over UT. Now, QU all over UT, because of these parallel lines, you see these parallel lines again? It should be equal to what then? It should be equal to QS all over SD. And then we'll tell them why are we saying that. We're saying that because we have a line which is parallel one side of the triangle. But we know what is QS. What is QS? What is QS? It's 2P. So we'll come and write this thing here, okay, and say, okay, here you have 2P. And then what is SV? Okay, this one is 2R. Now, guys, 2 and 2 is fine. This is simple maths. 2 and 2 they can divide each other out. That one is not a problem. 2 and 2 they can divide each other out. Then it means with ratio QU all over UT is going to be given as P and R. That's a problem because the variables are supposed to divide each other out. So now you have a variable, 2 different variables. You have P and then you also have what? R. So what then do we then do? We go to our original diagram. On our original diagram, we're going to try to get R to be P or P to be R. Now, if you look at this length here, SR is 3P. Now, another way you can get SR is to say SV plus VR. Do you see that? Another way to get SR, starting from here to here, it's SR. What is SR? SR is 3P. So I can write it that way and say, okay, but SR is equal to 3P in terms of P. Another way in which I can get SR, but why did I choose SR? Is because SR is the only person that has R. It has R and then it also has P. Another way I can write SR is this way. If I want to write SR in another way, I can write SR as SV plus VR. Do you agree with me? SR plus SV is going to give us what? SR. But we know what is SV. What is SV? What is VR? 7R. Then this is equivalent to SR. This is also equivalent to SR. This one is equivalent to SR. This one is also equivalent to SR. Then we can then say, but this thing here can be written as then 3P is going to be equivalent to 9R. Now you can either make R or P the subject. How do you make P the subject? You divide by 3 again. Divide by 3. If you divide by 3, P is going to be equivalent to 9. If you say 9 over 3 gives you 3, it says this is going to be 3R. What does this mean? It means everywhere you see P, you can come and put what? You can put what? 3R. Then you come and put there. Now one of P is over 3R. Then you have 3R all over R. R and R, what is going to happen? They divide each other, and then you're going to have 3 all over 1, all over 1. Usually you don't write the 1. But since it's in a ratio form, then we need to represent it as 3 is to what is to 1. So what is the goal here? Go and get your triangle section. And then after getting your triangles, it's fine. Use different variables. And then after that, you try to convert the other variable to the other one. Then we do the following now. Yeah, this one is a class work. So in this one, we are doing what we did yesterday and then what we are doing today. So we're going to combine the two. Let's do the following here.